I'm from Greenfield. We have a shop, fabrication machine shop, and we do a lot of work for ORPC. Do a lot of work for Mick, and basically that's it. Other people design, and we do the building. So that's it in a nutshell. So.
You built all of the structures for us to do work on.
I did, yes.
Yeah.
I do a lot of things.
And to clarify, kind of what Jimmy seems to do is, the harder the project is, the more you get phone calls back and the more enthusiasm. You know, most people who can do fabrication and machining, you know, they say, well, I have never done that before, and you don't hear back from them. Jimmy's just the opposite. He says, I haven't done that before, and you get, and then he says, can I come over and see what you're doing? You know,
we definitely do work outside the box. Actually, we don't even have a box. We just, everything we do is different. So we are a job shop, and just very, very neat projects between ORPC and the university. So it's, and like I said, that's just a small portion of what we do. We actually do mill work. We go all the way to Placa, Florida. Got jobs in Sacramento, California, with Jackson Labs. So we just do a very, very wide range of things. So that's about it.
Thanks, Jimmy. All right. Next person is Ryan Beaumont.
Hello, Ryan Beaumont. I'm a principal engineer, owner of a small engineering consulting firm in Brunswick. I'm a former University of Maine grad, and obviously a lot of familiar faces around here. Mick is a former professor, of course. I have been working on the ORPC project here, counted last week. It's been since the summer of 2009, so I've been involved since the beta project, the one that's out on the barge that some of you may have seen. I have been a part of the TideGen project, the RivGen project. Mainly what we've done on those projects is all the structural steel fabrication, all this, the engineering involved, so all the subsea structural work. It's probably about 100 tons of steel design work that we did for that project. We also have a separate division where we put together instrumentation packages, SCADA packages, and control systems. And we've been a part of the ORPC testing program from the beta and through the RivGen and the TideGen as well. I've been very happy with the training that the graduates have been getting, especially as a part of this Tidal initiative. I've either hired or stolen people that have been affiliated with ORPC or the Tidal Power Institute, and they do get a very good training and foray into tidal power as a result of all of the programs they go through. Well, if you have questions, I'm here.
So some of you heard about me. I'm Johanna Zillery. I'm with SW Cole Engineering. Technically, I'm a soil and wetland scientist with SW Cole Engineering, and I do a fair amount of natural resource permitting as well, and that's how SW Cole became involved in the Maine Tidal Power Initiative. We said 2009, we'll stick with that date. So we were initially engaged to work with the town of Wiscasset and to help them figure out the permitting process, to begin working with the Federal Energy Regulatory Commission and then the other state and federal agencies involved with the permitting process. And in that, we wanted to try and help figure out, is there a process that we can develop that will work for other sites that they can start using and hopefully improve on the process as well. I wouldn't be doing a service to SW Cole if I didn't say that we have ecological consulting, geological, geotechnical, and then construction materials testing. So clearly it's a hope of SW Cole that as tidal power becomes more widespread in Maine, that there'll be more business opportunities throughout the company.
Thanks, Jeffrey.
Hello again, Glenn Markey from ORPC, Project Development Manager. I've been with the company for 3 years, so I've seen the Cobscook Bay project from concept to FERC application to license submittal to grid connection. Pretty exciting stuff. This summer just blew my mind. Again, it's been a great team effort. The community support has been fantastic. Contractors, such as a couple up here on the panel today, have been wonderful to work with. Experience in startup technology companies. Previously worked for about 8 years in a similar environment, background in environmental policy and science, and just really happy to be here. So.
Good. You had a short presentation. Did you want to go ahead and give that?
Sure. I mean, moments ago I handed a video to Gail in case folks wanted to take a look at it. It basically summarizes the fabrication, assembly, and installation of the TIGEN system in Cobscook.
I don't think that'd be a bad way to start out.
And we'll just get going. Yeah, there's actually not much sound, so maybe I'll just do my best to kind of narrate over it. There is a little bit at the beginning from our CEO, Chris Sauer.
You can narrate over Chris.
Yeah. We'll talk over Chris.
He's just the boss.
So we did have, this is an animation, of course. The water's not exactly that clear in Cobscook Bay. So we did have a dedication, which was the best opportunity for the public to look at the full device before deployment. It was a great event. The bottom support frame was put down in March. The crew took a few minutes to commemorate the event. I think that might be Bob Lewis right there. There we go. So, most of the work was done outside. A lot of the components from Newport Industrial Fabrication out of Newport, Maine, arrived in Eastport and were assembled on site. Our main contractor is a joint venture between Morrison Manufacturing and CPM Constructors out of Freeport. They're known as Perry Marine Construction, PMC. And they've utilized a leased area off the boat school property for the sub-assembly activities for the project. So the bottom support frame, again with those pile guys on it, was transported to the pier, motored up to the project site. On a beautiful 85 feet. And again, to give you some perspective, at mean low water, we're roughly 82, 83 feet. And that's the operational window that they have out there, is just during the low slack water. The crew orchestrated a lot of the activities in advance, so that the short time window, the goal was achievable. Hard hat divers were deployed to do initial visual inspection, make sure that the unit was placed where it was supposed to be placed. And we have a little domestic plug there. So that's the bottom support frame. That had a chance to soak for a while. We did secure that with 10 30-inch diameter piles. It's a shot of Bill Corbett, our senior electrical engineer, doing some wiring and splicing, getting the cable prepared for deployment. There's plenty of duct tape involved. And again, a testament to the contractors that we have working for us. They outfitted the barge with the spools and the reels. We utilized a shear plow to trench the cable in Cobscook Bay, roughly 3,800 feet from the TIGEN location to the intertidal zone, and then another 400 or so feet on land that was trenched up to our onshore station. No, it's very tight, very small. After the cable was deployed, the turbine arrived from the manufacturer Hall Spars and Rigging, Bristol, Rhode Island. Very high-end composite manufacturer. Very happy with the foils. They were connected to the chassis. Oh, there's Bob again. Hey, Bob. So you'll see there, if you're not familiar, we do have two sets of turbines flanking the generator. A very windy day in Eastport. No, kidding. And so finally the day did arrive where, similar to the bottom support frame, the TGU turbine generator unit was prepared and lifted, loaded to the pier. The final weight, somebody can help me out, I think it's roughly 40 tons, 83,000 pounds. So that chassis will be, you'll see it in a moment, but that's mechanically attached to the bottom support frame that was sitting at the bottom of the bay.
Were the pilings put in first and the frame set on them, or was the frame there and then the pilings?
The frame was placed prior to the pile. Yep. So we're actually ahead of schedule by a day or so. So August 14th, we went ahead and got the green light. The weather was good, conditions were good, sea state was good, the crew was ready, and we held our breath for how long, Jarlis? For a while. It's a little bit difficult to see, but this is a diver video, which essentially shows the end of the deployment with the chassis mating with the bottom support frame, initially secured at this point.
Coming down. Coming down. Take Andrew out of the water. Roger that. Coming up on you, Andrew. Roger that. Down on TV. All stop. All stop, Roger.
So manually secured with a few U-bolts to start out with. And then they went ahead and did all the final torquing. And so we were extremely happy with the operation. Couldn't have gone any better. The crew was fantastic. Staff was great. A quick shot of our onshore station in North Lubeck, where again we started putting some juice into their grid last week. So it was it's been great. A lot of work is being done still. A lot of debugging, a lot of software updates and so forth. So it's been a great ride. And you may have noticed, we didn't utilize any special vessels. We just took advantage of the expertise, the marine tradesmen up here, and the equipment that's available. So that's about it. I don't really have anything else prepared. I'd be happy to answer any questions.
That's cool. Well, I would like to. I mean, that's a great segue into kind of what the pieces are that went into that. And I'm going to give it back to Jimmy and ask, Jimmy, what pieces of this were you involved in, and how do you compare the complexity to, working in a mill or some of the stuff that you started out, built your business on?
I think the main thing for the tide gen was the material. There was a specialty stainlesses that we used. I think most of the stainlesses are used down in Texas. It was, getting down the welding processes, machining speeds, feeds. It was a difficult material to use. And I think other than that, because we work on such various types of projects, I really think that was probably the most difficult area, was just the material.
So Ryan, going back to the material selection, how does that tie into some of the engineering challenges that you would have ended up with associated with the same sort of project?
Yeah, for me it was speccing steels, just standard grade steels that would be used in other applications. Low temperature was a big deal. We needed to choose materials that could work down at these depths, these temperatures, so they needed to have a significant amount of fracture toughness, which when you add that to, it's a material that's in a subsea frame, so it has to also meet other standards. It was, and then finding something you could source and that you could actually buy without having to put it on a train in a 1,000-ton order from Texas was really what the challenge was. So sort of a compromise was selecting some of these materials. The stuff that Jimmy worked on, all the driveline components, the stainlesses and that sort of stuff, I think all that material came from either England or the West Coast, or really only one or two vendors in the world that sell that sort of stuff. And it was it's a super duplex stainless. It was required because of the design life. There's a very long design life. I think 20 years, 15, 20 years was a requirement. So your typical 316 stainlesses that you would maybe see in a paper mill or something would not hold up over time. They would be subject to cracking, stress corrosion cracking, that sort of thing. So these sorts of steels are used for this particular application. And Jimmy had to deal with working with them.
So, do you see those skills as transferable to anything? Let's say beyond even tidal energy. Is there any kind of work that you've looked at that would transfer those skills?
Yeah, all the subsea work could transfer basically to any other subsea applications, and like there's a pile of work in Texas if you want to go after it, for drill rigs, for various offshore oil standards are developed around the design of these subsea structures for drilling, for exploration. So all of those sorts of things are applicable in that industry, and that's actually the industry we looked at in order to adapt and develop our design. So yeah, all that sort of all the offshore oil stuff is completely applicable to this, which is, it's great. You're taking a skill set that was developed in another industry and applying it to a new emerging industry. I think it was a good net result in the end.
Transferring that then, let's talk jobs. So how many people do you have employed? I'm not necessarily connecting the dots on this, but how many people do you have employed? How many people work for you now?
4 full-time, 1 part-time, so 5 now. And as of 2009, it was just me. Yeah. So it's been some growth.
And what are the jobs? I
have 4 engineers, including myself, and 1 office admin. So it's 3 3 technical jobs, high skill technical jobs, graduate level jobs, that sort of thing coming, out of Maine, and all of my employees have ties to Maine. That's the other thing. They didn't all come from University of Maine. Curtis was a Maine Maritime grad. Seth is an Islander. He grew up on Cranberry Island, moved back to Maine after going to Wentworth because he wanted to live in Maine. And Jeff's a Maine native, and he's still here.
Glenn, how many jobs, do you have numbers of direct jobs that you're looking at right now in Maine? the direct and indirect?
Yeah, sure. I mean, you know, we're hovering around the, you know, from the pre-commercial efforts, beta program through TIGEN. You know, we believe we've had around 100 jobs, direct and indirect. ORPC, we have 24, 25 full-time, most of which are in Portland. We do have a small staff in Eastport, obviously, and then we have a small staff in Anchorage, Alaska.
So, Jimmy, I know you're a lot more diversified. I guess it's hard to say. How many people work for you now? I mean, you've got some, you have some ebb and flow too, right?
Yeah, there's 7, 5 basically in the shop, and I mean, we've always kept that many people around, but the problem is with the economy the way it was, without the RPC work, I mean, it probably would have meant less numbers that I would have had in my shop. So, I mean, really, it meant a lot to have the work come from them, so, yeah.
Johanna, to give you a challenge here, you've had kind of a different role in this as far as like regulatory and building the skills within SW Cole for a new industry. What's the next step for SW Cole on this?
Boy, I think the neat thing for me is how transferable some of this is in terms of permitting and working with the agencies and other stakeholders. It's neat how similar the process is between different projects, whether it's tidal power or a development looking at other natural resource alterations, wetland filling, dredging. So it's just neat kind of working with the different stakeholders, the client, to kind of achieve the same, to achieve a mutually agreeable goal. I think the next step would be a challenge probably to all of us to work among the MTPI group, to work with regulators, to work with the engineers and say, how can we move this further down the road? How can we maybe develop an array, a turbine that's more fish friendly? Is it possible? Let's at least start talking about and thinking about that.
So, do you see any ways this has helped SW Cole, or we'll go down the other 3 of you, I'll leave ORPC out of this one. Do you see any ways that this has made you more competitive as far as the broader set of skills?
I think, again, like going back to the transference, how much these skills are transferable to things that SW Cole has traditionally done, and I think it broadens the markets that we're applicable to. So that's, and I've seen in either a presentation that Herb or maybe Chris Sauer did, I've seen the economic impact slide that's basically a whole bunch of bubbles in the state of Maine, and I can attest to that because a couple of the projects and sites that you talked about, not working for RPC, but someone that we consulted with that ended up working for you is a project that we worked on, so it's neat to kind of see that ripple effect grow.
Ryan, I'll give you that same one.
What was the question?
Competition and specifically learning, and I guess we mentioned some of these fabrication and material selection. What about on more the instrumentation side and all that? Are you seeing any other skills that developed out of this?
Yeah, certainly we've come across a lot of things around subsea instrumentation that we never really dealt with before, and it's a very different world. So we've certainly broadened our skill set and portfolio there. I think the main thing that this has allowed me to do, this project, is it's allowed me to you know, kind of focus on both the business and the engineering, whereas before I was solely focused on the engineering. So I've allowed to, you know, by taking on a staff, you know, have a core staff to help with all the engineering related work, and I can, you know, focus on the business and expanding to those markets that I, you know, see potential growth in.
Well, I was kind of giving you an opportunity to segue into some of the stuff you did with the testing in the wind related.
Oh yeah, sure. I was
giving you that opportunity.
That's so long ago now. A year ago. I mean, yeah. We've as a part of, you know, knowing a whole group of people. Everybody has their fingers in a lot of the same things here. I've been able to work on the offshore wind project as a result of being involved in the renewable energy sector in Maine. So I've worked on some sensors instrumentation type work for offshore scale model testing, specifically the test at the wave basin in Maine, the 150th scale, the floating offshore turbine. So yeah, certainly, and also, I mean, as far as all of the related work that I've done, we do quite a bit of work in the paper industry as well, and not so much in Maine, but as far as there's still a few core people that we support that are suppliers to the paper industry that we support in Maine, and we kind of can leverage both of our experiences in both sectors and kind of share knowledge that's gained from each and how it applies to both types of projects. So.
Yeah, you're welcome.
As far as it's just basically getting back to the materials, and it's probably nothing that we'll ever go to Texas with, to look for work. It'll probably be basically RPC that I use, what we learn. But I guess the main thing that we probably learned out of the whole thing is a lot of patience. So, a lot of patience. So, yeah.
Well, is there anything that any of the, I'll leave it to any of the four of you, next steps that you'd like to be seeing coming out of this group as far as the Maine Tidal Power Initiative to support the industry, I guess, is the other part of this.
I mean, personally speaking, I think that the model and the efforts that MTPI has put together and the group of people that are here now, we've kind of demonstrated the potential. And I think that this kind of collaboration needs to continue. It should grow. We've taken both as a company and UMaine, we've certainly reached out to the communities, and we've had pretty decent support, but the participation probably could increase on the community level. So maybe that could be a goal, is to further engage and help foster that relationship and make it a little bit more sustainable longer term.
Well, I looked at four of you, or the three of you on here on the support on the geotechnical side, certainly as far as the skills with Jimmy, the permitting associated with SW Cole, and the instrumentation associated with, right? I mean, in particular, the site assessment on the geotechnical side. This is a big piece that's needed for the industry. We've heard mention that there are some clusters of people outside of Maine who are looking at this, but this is going to be a services industry that I can see everybody contributing to, as well as the infrastructure for the assessment. So
yeah, anything that's developed as a part of this project in tidal power for the site assessment can be adapted to site assessments for offshore wind and other industries that might be growing offshore. And if we beat the Canadians to the punch with some of these technologies, we can also offer those types of services to that market as well. So.
Okay, were there other questions for this panel as far as like what's happened in the industry? Please,
yeah, just curious about, you're talking about potential growth with maintenance. Like, would you guys take on like future maintenance of these things? I mean, as things go wrong, as you put down arrays, there's going to be issues. You're going to pull them up. Would you grow into a maintenance component, or would that be somebody else?
Not me personally, no.
He was looking at the cubicle, not the boat.
I might let Glenn respond to what's currently in mind for maintenance.
Can you reach the mic, Charles? No. We do have an operations and maintenance schedule and a plan, and it's a big component of the project. Right now, I believe that it'll be our contractor performing most of those duties, and we'll see how that goes. Yep. Yeah, I'm sorry, Perry Marine Construction.
Joanna, anything next out of the MTPI that you or Jimmy, either one of you?
I think like you mentioned, Mick, the bigger piece of tidal power in Maine is trying to figure out how we can extract energy from the sites with flow that's probably closer to Wiscasset, and then moving forward, assuming we can do that, being optimistic, how can we make it so that municipalities have an easier time with the permitting and regulatory process? So that's something that I think regulators, stakeholders, consultants and engineers and biologists can all work together on it. I think that'd be a pretty neat thing to pursue.
And providing the services then that underlie it's not only the permitting, but also the services that underlie the evaluation of that.
Right.
And I might mention building the equipment that's needed for
that too.
for evaluating the services. Are there any other questions for the panel? Okay, thank you very much.